Today we will understand how to run the analysis when you have model with you and you want to establish the relationship between different IB and DB. As discussed in class, I have different IBs, independent variable and dependent variable. So as my topic was meta boards banking adoption, I had different independent variable which were trust, then nobility, then perceived relative advantage, and these were many independent. I had seven independent variables. I'll tell you step to a step process after getting the data how to examine your hypothesis, that your hypothesis is supported or not. So moment you will fill the questionnaire, this the response you will get. You have to go to response. After that you have to click on view in sheets. Moment you will click on this this type of form will come. Now what you have to do, you have to go to file and there is option called download. You have to click on download. There is option called Microsoft Excel. So this data will be saved in Microsoft Excel in form of response. First, for better visibility, you have to change the color of first column. That is the first thing that you first thing that you need to do. After doing this, next thing what you need to do, you need to delete time first. Then as I asked roll number, it's not required. You need to delete that. First thing what you need to do, we need to check, as I had put screening question, we need to get the data only who has filled yes that they are the eligible respondent. For that, click anywhere on the Excel sheet, then you go to filter and sort, click on filter. So on all column there will be filter activated. Then what you need to do, you need to go to filter here and you have to select only no. No means these are the respondent who selected no to your screening question, so definitely they will not get the response. And then after what you need to do, you need to delete these all responses. So I have deleted all that. And then after I will come here and I will select yes. So these are the responses which I had received are actually eligible for this. Now after that we need to delete this column also. Now next thing is very much important, that we need to identify that who are the respondent reading my questionnaire. And for that I had asked two check question. So if I'll go to column number N, I have asked one question, please select agree for this question, and I have given the response that 1 for strongly disagree, 5 for strongly agree, and for definitely because of that 4 for agree. So what I will do, other than 4 other responses, if I am receiving other responses, it means these people are not reading my question. This we call attention check question. So we will select 1, 3, 5 here because 4 is the right responses. So these are the responses who are not reading the question properly, and I will delete that. And after that I will select 4 here, and then I will delete that column also because this is not my study related video. Again in one I had asked second question here, please select a strongly disagree. You need to ask 2 check question because sometime it might possible by chance they filled the right option. Here strongly agrees for 1, so other than 1 all the responses are invalid, so I have to select there and I need to delete that rows. So I need to go there and I need to delete that rows. After deleting this rows, again I have to select here 1 and then OK, and then I have to delete this column 2. So this we call data cleaning. Data cleaning means first you need to understand that a screening question you have asked that they means they must be your respondent, and then through check question we understand that they are reading the question. After that we need to do the coding process. In coding process what you need to, which is very much important, which I have discussed in class also, that first you identify all the variable name in your model. So in my variable name, and it should be in the sequence which questionnaire are there. So first 3 question I asked related to adoption intention. Their code is AI. How many items I have? 3 items, and column 1, 2, 3 in sequence. Then perceived compatibility, code is PC, item 3 item, then definitely code will sequence will be 4 to 6. This is very important. My suggestion, take a print of it or write on pen and paper that what are the variable in sequence, what the code you have used, what are the items, how many items, and what are the column they are going with. For that, and after that what you need to do, first 3 question is related to adoption intention, and what code I have used? AI. So I'll go on that data. First 3 column is I will write AI1, then AI2 and AI3. This is the questions related to adoption intention, because it's very difficult to remember the questions. That's why I'm doing this. Then I'll go back again. PC, perceived compatibility, 3 question. Perceived compatibility, 3 question. So I'll come here. Perceived compatibility, PC1, PC2, PC3. This is very much important because this helps us in coding, and this will it will give me understanding that which question I have asked for which variable. Then next we have real time interactivity. I have used RI in 4 question. So 4 question for real time interactivity, code is RI. So I'll go there, and for 4 question I'll write RI1, RI2, RI3 and RI4. These are the question related. Sometime you can go back after some variable, you can go back and check that sequence is matching or not. Next we have novelty, code is NB, and I have 3 items, NB1, NB2, NB3. Now after novelty we have privacy and security risk. I have used the code called PSR, PSR1, PSR2, PSR3. Then we have code called variable called playfulness. Code we are using play, then temporal dissociation, and then perceived relative advantage. So I'll go there, PSR1. So PSR done. So now playfulness, play 1, playfulness 2, playfulness 3. Then we are having temporal disassociation, TD1, TD2, 4 items, and perceived relative advantage 4 items. So I'll go there, TD1, TD2, TD3, TD4. So I'll go by that, TD4. Then I will go for now next item, which is, it's still TD4 only, TD5 not, we don't have TD5. So this is nothing but perceived relative advantage, PRA1. We have asked 4 questions for that, 1, 2, 3, 4. So PR4. So this is related to perceived relative advantage. And then we have the 3 question which is related to trust. Code is, we have used T1, T2, T3. So first thing you have to do the coding. So I am providing the coding part. After doing the coding, what we need to have? We need to have gender. So with this data, these are the demographic data which we have collected. With this data I need to first create. So this is called coding process. So I did the coding. Now with this demographic data I need to create table number 1, which called demographic table. I have already created that table. In that table, these are the characteristics we have. Demographic, gender, we have collected data, male, female, prefer not to say. Another option is also there here, is called others. So these are the four options we had. Then we have age, education qualification, income. These are the 4 criteria which I have asked. Now in gender, there are many 4 criteria. So first we'll check how many female are there. So female we have in number is 110. So 110 female, male is 93, 110 93, not prefer to say 1 and others 1. So we have 110 93 11. So I'll go there in that Excel sheet. I'll write here count male 93, 110, then 1 and 1, and we need to check that total responses is same or not. So how many response I have as total response I am having 205. So I need to check that 205 is matching or not. So total is coming here 205, perfectly fine. In percentage, what I need to do, I need to use formula this divided by 205, and you have to format. You might get in the decimal. For that you can go to the format cell. You can make percentage decimal place too, because sometimes it might give you the not the percentage data, but it will give you decimal data. Now I'll go to the age column. Now I'm going to the age column for my data, and in this age column we have only 2 age because I have collected data from you people. That's why responses are skewed, but this is for training purpose, so definitely this will help us. So 140 we are having as 15 to 25. 140 we are having 15 to 25. So I'll go there 15 to 25, 140. So remaining 65 will come here, and this same formula will work, percentage formula will work here because that will not change. Now it comes to education qualification. In education qualification, now I'll go to higher education. There are 2 things we are having, graduate and postgraduate. We have how many graduates that I need to check first. So in terms of graduation, who has already completed the graduation, we are having 190. So 119 response for the graduate. Definitely others will for the postgraduate, because we have only 2 options. So 119 I will put here, 119, 119, and then here it will be 205 minus 119. This will be the remaining one, and percentage formula will remain same here. Now next is income. Income is very much important, so I'll go there. Again I have different options we are having here. Below 50,000, 50,000 to 1 lakh, 1 lakh to 2 lakh, 1.5 lakh, 1.5 lakhs to 2 lakh. It's monthly income INR. So first I will say below 50,000. How many people are there below 50,000 per month? So these options we have, and I think many responses. 173 response there, 173. Then 50,000 to 1 lakh, 173. Then we have 11. So I'll go there, 173. Then 11. Then I need to check 1 lakh to 1 lakh 50,000, 1 lakh to 1 lakh 50,000, 6. Then 1 lakh 50,000 to 2 lakh, 1, 6, 1, and 6, 1, 14, 6, 1, 14. So I'll go there in my sheet and I'll put here 6, 1 and 14, and again I need to get this percentage. This data is very much important because sometime you did this analysis, you submitted to your reporting authority, and then they asked, is this result will same for male and female? Then what you will do, you will divide your data set into 2 parts, male dataset, female dataset, and you will run the model what we am doing at 2 times, and then you will say that results remain same or not. Second thing, it's very important to see that you are getting the response from different cohort or not. So your response is generalizable or not. To see that, you check that how my demographic characteristics of the responses are. So this is very much important that you need to create, and this is the first table you will put in your report which you will submit to me. After doing this, as I told you, कि all the variable in our model is a latent variable or unobserved variable. So first we need to make sure that the question we have asked to measure these variables are reliable and valid or not, and for that we need to check reliability and validity of the measurement scale. And for that, first thing I told you, to measure the reliability we have indicator called Cronbach alpha, and Cronbach alpha value should be greater than 0.7, and then for validity we have scale called ABE and CR. ABE value should be greater than 0.5 and CR value should be again greater than 0.7. So first you create this questionnaire. Wherever you have questionnaire, this is my questionnaire. First you will create one row here. Here we will write variables and items. So this is my first column, variable and items, and then we will go with second column called factor loading. We are using the term called FL. Then I will write AVE, then we will write CR, and then we will write alpha value, Cronbach alpha. Alpha means I am talking about here Cronbach alpha. So these are the value I required. So first we need to calculate our factor loading, AVE and CR and alpha. So first we will calculate Cronbach alpha to see my scale is reliable or not. And for that you need to open RStudio. I am opening RStudio because this analysis we can do in RStudio, and here we will do this analysis which we call structure equation modeling in RStudio only. So we will open RStudio and then we will do the analysis in RStudio. I will take you from scratch that how to do the analysis, what are the packages required, and then we are good to go. I am opening RStudio. Moment you will open RStudio, your RStudio will look like this. So this is my RStudio which I am having. Now first thing, I have shared one code with you. First you can copy and paste that code which I had shared with you. This is the code which I had shared with you for structure equation modeling. So copy and paste this code first in your script. So we will paste it in a script, and then we will do the analysis. So first thing, we need to calculate the Cronbach alpha. For calculating the Cronbach alpha, first we need to upload the data set. So whatever final data set you have received here in the Metaverse banking, just go there, close all the filters, and then in the file save with one name. I am saving it on my desktop. So I am saving this on my desktop with the name called data new. So I have said the name called data new, or I am saving with the data only for better understanding purpose. I am saving data on my desktop. So I have saved this with the name called data, and then I'll close it, and my RStudio is there. First I need to upload the data. To upload the data, go to import any data set. Here you will click from Excel, browse option. My data is on desktop with the name called data. I'll upload this. Preview, I can see that AI1, AI2, AI3 is there, perfectly fine. Name is data, and then first row is a name. Just import this. So can you see we have 205 observation, is 205 data points with 34 variables, perfectly fine, with 34 columns. Now first I need to calculate the Cronbach alpha. To get the Cronbach alpha, I need to get it variable wise, and these items are at different place. For that, what I need to do, I need to check in such a way that first we will convert into the table, and then after we will do the analysis on that. So creating the table, I am creating a table name called new data is equal to create the table, the function I am using called data.frame, and the base file name is data. I am running this code. What happened? New data table came. Why I am creating in the form of table? Because I need to get positions of a specific items. When I am saying item, it's question. That's why I am doing it. To get the Cronbach alpha value, the function I am using called alpha, my table name is new data. Moment you are starting the third bracket, it will talk about position. So first they talk about rows and then columns. So when I am getting a space means all rows, column we are talking about 1, 2, 3. So 1, 2, 3 is there, and this again this table will help you a lot, which we have prepared. If you remember, there I prepare a variable name table, adoption intention, item 3, and column number is 1, 2, 3. So 1, 2, 3 for adoption intention. I'll go there and run this code. You will get Cronbach alpha value. I am not getting because running this analysis you need 2 packages. So first package required called Lavan. So you search Lavan is there or not. If you don't have, you need to install it. And second package which required called Psych. So these are the 2 packages we required. So you just check Psych and you check Lavan. After that you run this code. Moment you will run this code, you will get standard alpha. Can you see here it's standard alpha which is coming 0.92. Good to go. If it is more than 0.7, no question asked. So for adoption intention my alpha value is 0.92. Then again I will go to R. Next, my next variable is, I will see here what is my next variable. My next variable is perceived compatibility, PC I have used, and 3 items. So I will go there. Sequence is 4, 5, 6, 4 to 6, 3 item, and then run. It's coming 0.87, 0.87. You have to check a standard alpha, STD alpha here. It's perfectly fine. And then again you will go there 0.87. So sorry. Perceived compatibility because this is item wise, so I am putting 0.87. Now we have 4 questions. So I will go to our studio again. For 4 questions I have 7 to 10. This you write down somewhere, so it will help you a lot. Cronbach alpha is 0.85. So I will go there and 0.85. Then next we have novelty 11 to 13. Now I am facing the problem Cronbach alpha is less than 0.7. So as I told you in class, if your Cronbach alpha is less than 0.7, you have to see the next table which talks about reliability if item dropped. So if I will drop NB1, my Cronbach alpha will be how much? 0.39. So we should not delete that because after deleting NB1, my Cronbach alpha is going down. It should increase. NB2 0.5. So you need to check is after deleting any of the item, are we getting Cronbach alpha greater than 0.7? That is the thing that you need to see. Now I check that after deleting NB3, we are getting the Cronbach alpha. So what I will do, I will go there and I will delete in my data set, from my data set means from my model, NB3 will not be there. So I need to delete NB3. So now I have 2 items, and in this code to check it that it's working or not, I make 11 and 12 and I'll see if I'm getting 0.72 or not. I'm getting Cronbach alpha 0.72. So the next value I'll put here for novelty, and that you need to understand. You need to delete the item if you are not receiving your Cronbach alpha. Still, if for example, still I am receiving less than 0.7, then what you need to do? You need to delete the variable because variable can't have 1 question. It should be at least 2 questions. Now, perceived security risk. I'll go to there again 13, 14, 15. So 13 to 15 for perceived security risk. And I got this no sorry 13 was there related to NB, so I have to got 14, 15, 16. 14 to 16 was this for this. Again this table will help you a lot, that I discussed again and again, that this table is very much important. 14 to 16 is for PSR, that is not changing. So run this. 14 to 16 is 0.85. 14 to 16 0.85. So I will go there and I will write 0.85. Then for playfulness I go again into this 17 to 19. .93. Then next TD and PRA 4 items, and then trust. So I'll go there 20 to 23 because 4 items we have. .93 again, and again I am checking it here 24 to 27. So 0.93, I'll remember this. Then 0.93 again, and last but not least for trust, it's coming 0.85, 0.93, 0.93, 0.85 for consecutive variables. So 0.93 again, 0.93 and 0.85. So that first you need to, so I need to make sure that all Cronbach alpha values should be greater than 0.7. Now I need to calculate AB and CR, and for calculating AB and CR we need factor loading. So to get the factor loading, first you have to develop a model. So I am developing a model. My model name is model. My first variable name is intention. I have used short form. How I measure intention? AI1, AI2, AI3. Compatibility PC1, PC2, PC3. Interactivity RI1, RI2, RI3. Novelty, here you need to understand, if some of the item or variable get deleted, you should not put in your model. For example, if novelty whole variable get deleted, you have to delete whole variable here. In my case, only one item got deleted, so I am deleting NB1. Other thing will remain same because there is no change. I'll run this model. So I am telling the R machine that's how I have measured different variable. You run this model run, then to get factor loading, as I told you in class, we are running confirmatory factor analysis. So for confirmatory factor analysis, I want to save the output with the name called fit. The function I am using called CFA. What is my model? Model is my model name is model. And which data you are using? Called data. So you have to use your file name. So for example, your data name is mobile banking. You will write here mobile banking. Simple. Run this. Then we will go for summary fit standardize. Run this, and in this summary fit standardize, before running this, you can increase the breadth of this column. So you will get in this quadrant. So you will get in one go. So that you will get. You have to copy which one. You will get one table called latent variable table. You have to copy this result of latent variable table only, because latent variable give you the factor loading. Latent variable give the factor loading. You copy this, and I'll tell you which one is factor loading. You go in this sheet only, and you paste somewhere. So I'm pasting it here. Now it will, as I have copy paste from R, it will be coming as text data. So I need this data in different column rather than in one column. So I'll go to data. I'll go to data text to column, and I'll get in different columns. So this last column is the standard all is nothing but your factor loading. So first you need to check that all factor loading p values should be less than 0.05. That is the first thing. And then after this is the factor loading that you should use. So I'll copy the factor loading because that is in sequence. There is no change, and that's how sequence very important. I'll copy it, and in the factor loading column I'll paste it here from this item. From this item I'll paste it here because this is not for variable, this is for item. So can you see I got all the factor loading here, and after that you can delete the table. The only thing you have to check that their p value, all p values should be less than 0.05. If it's not there, then you have to delete that factor loading and item. So that you need to delete, it's not less than 0.05. Now this will help me in getting the AVE. How to calculate AB and CR? So if you remember, I have shared one Excel sheet with you called AB and CR template. So you copy this factor loading of the variable 1, you go to AB CR template, you just paste into the loading. So you have to paste here in the loading. So there is a loading, you have to just paste here. There were only 3 items, you need to delete all the other options. So your AB is 0.79 and 0.92. You will go there and you will write 0.79 and 0.92. Good to go, because as per rule AB should be greater than 0.5 and CR should be greater than 0.7. Good to go. Now again for the next variable, I will go there, I will paste here. I am getting 0.7 and 0.87. So I will write here 0.7 and here I will write 0.87. The next variable is 4 items I am having for real time interactivity. I will go there and again I will paste it. Now it's 4. I need to drag this. I am dragging this 2, and then I am getting here 0.58.84, 0.58.84, 0.58.84. Then next we are having to, one thing I observe here, see, this is standard factor loading. It should not be greater than 1. If it's greater than 1, there is certain error. So if there is error, I need to delete that item. Moment I am deleting that item, novelty have only one item. So one item variable not exist. So what I need to do? I need to delete that variable. So I am deleting novelty my model, means my hypothesis got deleted. Novelty related hypothesis gone. Now Control C again for privacy and security risk. I'll go there and I will check privacy and security risk. I had 3 items, so I delete the fourth one, 0.66.85. So I'll write here 0.66, and here I will write 0.85. Then next I am going to measure for playfulness. Control C. I'll go in this AVSER, and the value I am getting 0.81.93. 0.81.93, 0.81.93. Then next we have disassociation. I will go there into AVCR and paste it, and then you have to drag it down, and then 0.77.93, 0.77 and 0.93, 0.77 and 0.93. Then next we have perceived relative advantage. I'll copy it, and then I'll go here, I'll paste it here. It's going 0.77.93, 0.77.93. And last but not least, we have trust. So I'll go there again, ABNCR, I paste this, delete this one. I'm getting 0.68, 0.86, 0.68, 0.86. So first table which is required called demographics, second table which is required called factor loading, ABNCR. This is the second table which you will submit in the report. Means we need to make sure that my scale is reliable and my scale is valid. For reliability, indicator is that Cronbach alpha value should be greater than 0.7, and for validity, the Cronbach alpha value for validity AB should be greater than 0.5 and CR should be greater than 0.7. So these are the table which required to understand that we are having reliability and validity achieved. We are having reliability and validity achieved. And at this stage, either there are some item will get deleted or some of the variable will get deleted. So this we call ABNCR. Now once it is done, we need to check my hypothesis. To check your hypothesis, again first I need to work on my model. My model look like this. You see my model, same thing will happen. Now I am creating a model called model 1. Intention measure like this, compatibility with this, interactivity with this, novelty with this. Now novelty will not be there because I have deleted from model, because they are not having reliability and validity. So you have to delete from here, and you have to delete from regression equation also. So what I did, I first tell the machine how I measure this variable, and then I have written my dependent variable is intention. So you will write your independent variable here. Dependent variable, whatever your dependent variable implies that all your independent variable with plus sign. One thing you have to very much cautious that this spell should remain same what you have, how you have measured here. Second thing, this name of item should be the same as the column name which you are having, otherwise you will get the error. So this is my whole model. The only change I am making with CFA that I am adding relationship also. Okay, what is my independent variable, what is my dependent variable, which will give me the regression data. I'll run this, then I will check fit 1. The code function I am using called SEM. My model is model 1, data same data, and then summary fit standardized. I will run this, and then I will get this. You need to check in this called regression. So regression is very much important for me. Regression will talk about which is my hypothesis supported, which my hypothesis is not supported. If in terms of hypothesis you want to see, novelty is gone now. So in terms of hypothesis, these are my hypothesis. Can you see? Perceived compatibility to adoption intention, real interactivity to intention, privacy, playfulness, temporal distance, perceived relative advantage, and trust. Now novelty is not my model because novelty got deleted. I'll paste this somewhere, then will again same I will go with data, text to column, finish, then these are the coming in. So the last column is nothing but your beta, standardized beta. So you copy it and you paste in the as beta. This column is called, the first column is a standardized beta, so we are not looking for that. Standard error is this. So second column you will put here called SC, and fourth column is called p-value. Now based on the p-value, you need to they take the call that hypothesis supported on thumb rule. If p-value is less than 0.05 at 95%, your hypothesis is supported, otherwise not supported. So this hypothesis is supported. What does it mean? It means that perceived compatibility has significant impact on metaverse banking adoption. When I am saying supported and hypothesis is significant, it means that. Now second hypothesis not supported because p-value is greater than 0.05. This is not supported. This is not supported. This is not supported. This is supported because this is less than 0.05. So this is supported and this is not supported. So my conclusion or finding is that out of 7 variables which we had, only perceived compatibility and perceived relative advantage has significant impact on metaverse banking behavior. Means when customers intend to use it, these are very crucial factors. After that, you need to get your R square also, which talks about how much intention is explained by this independent variable. For that, their code in RStudio I have given to you is called inspect fit1 R square. Run this, you will get dependent variable only. Dependent variable R square is 0.718. So somewhere in the table you will write R square is how much? 0.718. It means the 71% of intention to adopt metaverse banking is explained by these independent variables. That you need to write. After that, the final thing which we are looking for in structure equation modeling is model fit. Model fit talks about how fit your model is, and there are different indicators as I discussed in class: chi-square by DF, CFI, GFI, AGFI, TLI, NFI, RMSC. This chi-square by DF should be its badness of fit, means it should be close to 0, and RMSC also badness of fit, means it should be close to 0. Other indicators should be close to 1. I will tell you the ideal value. That must be, you must be know the accepted value. So accepted value for this, and then you can compare that your model is having this or not. This accepted value will not go in the table. I will tell you what you need to highlight, but for understanding purpose I am writing that this should be at least 5, at least less than 5. It should be at least greater than 0.85. This should be greater than 0.85. This should also be greater than 0.8, and this should be greater than 0.85. This should be greater than 0.85, and this should be less than 0.08. That is acceptable value. Now we'll check how much value I am getting. To get the model fit, there is a code I am given called fit measures. So fit measures you need to run. You will get this value. You just copy and paste somewhere, so it will help you in getting this data. So I copy this result, and in my Excel sheet I am saving it here, and you will get value one by one. So see, what is my chi-square value? 523 by, so my chi-square value, because it's chi-square by DF, 523.34 divided by, what is my degree of freedom? My degree of freedom is 296 divided by 296. So I am getting 1.71, which is good. Now we need to understand CFI value. Where is my CFI value? CFI value is given 0.951. Good. I have good model fit in terms of CFI, which is confirmed factor analysis, confirmed fitness indices. Then GFI, goodness of fit indices, is I am having GFI 0.848, AGFI 0.80, 0.845. It's close to 0.85, 0.80. It's close to that. Then 0.808 we have for AGFI 0.805, sorry, 0.805 is greater than 0.8. Then TLI, we have TLI value is nothing but 0.942, 0.942. Then we have NFI value, NFI is 0.895, 0.895. Last but not least, root mean square of error approximation, NFI, norm fit indices, TLI, Tucker-Lewis indices, goodness of fit indices, segregated goodness of fit indices stands for AGFI. The only thing your model should be fit enough to achieve those values. We have discussed this in the class. So then this RMSC value is here. This is nothing but 0.061. 0.061. So that value you need to, so your table you will present here is this only, not acceptable value. That is for your understanding. So this table you need to present. So I am putting in nutshell what you need to do. You need to provide demographic. You need to provide the ABNCR table where you need to make sure that alpha value should be greater than 0.7, AV value should be greater than 0.5, CR value should be greater than 0.7. If it's not coming, you need to delete some of the item and some of the variable. And then after, you need to check which hypothesis is supported or not supported, and then you have to give R square and then model fit. These are the table I am looking for when you are submitting your report. So this is all about the analysis which we are doing. You can also copy and paste the diagram which is coming in R, but this is not mandatory. Thank you everyone. This is very simple step that you need to do from scratch, getting the data to analyzing of the data. I want you to do it very cautiously because I can run the regression after getting the data also. But when you are playing with latent variable or unobserved variable, first you need to make sure that you are able to collect reliable and valid data or not, and then you can run some of the relationship and you can check. And as I told you in class, this analysis will not only help you in removing the standard error, this analysis will also help you in removing the measurement error. Thank you everyone. See you in the class.